Okay, next is assignment 3. So the first question of assignment 3 already discussed in the class, so I'm going to proceed with question 2. So in question 2, a skater on Ottawa's Rideau canoe travels in a straight line 8.5 times 10 power of 2 meter, 25 degree north of east, and then 5.6 times 10 power of 2 meter in a straight line 21 degree east of north. The entire motion takes 4.2 minutes. So what is a skater displacement? So in order to find displacement, you have to understand that since that the question given degree, so the questions is a two-dimensional problems. If there's a two-dimensional problems, we have to solve by using vector, and we have to separate the vector into two different components, x and y. So what's the skater displacement for this one? So we analyze the motion first. First, this is where the skater started. Let's say we have a direction as reference. So north, east, west, and south. 8.5 meter times 10 power 2 means 850 meter north of east. So going to this direction, north of east, 25 degree, and then the distance is 8.5 times 10 power of 2. And then after that, and then 5.6 times 10 power of 2 meter in a straight line, but now it changed to 21 degree east of north. Means that when it reached here, it changed the direction again. So we can draw a reference here. This is north, this is east. If a east of north means that the 21 degree is here in this direction. Okay, and then the total distance travel is 560 meter. So I change this one to meter. It's easier for us to see. Okay, and then from this question, we can draw two triangles for this one. Easier for us to do and to analyze for further. So for this one, you can see that there's actually a triangle here. A triangle 850 meter with 25 degree. And for this one, you can see that the triangle is actually here, this place. Okay, so there another triangle we can draw in this form. The degree is here, 21 degree, 560 meter. And therefore, we have two triangles. And in order to find the resultant displacement, we need to find delta D. Delta D is what we wanted to find. Delta D is what we wanted to find. But since that this is a two-dimensional vector problem, so we have to separate into two different components, which is delta dx and delta dy. Okay, so for the first one, we have a first triangle, and we need to find the x component for the first triangle. So we have delta dx. So delta d1. So this is the first triangle. We need to find the total displacement for the first motion first, and we can separate this one into two different components, d1x, another one is d1y. Okay, and then we deduce a formula. This is the x coordinate and this is the y coordinate. Okay, horizontal is x, vertical is y. Therefore, this part it should be delta d1x, and this part should be delta d1y. For this one as well, this is the second one, this is the second triangle, so d2x, and this is delta d2y here. Okay, so you find d1x and d1y first. We know that this is a triangle, and we can solve this, find d1x by using a trigonometric function HA, and this is the opposite. So we know that we should, in order to find d1x, we have the information of A and H. So A and H we should use cos. So cos delta is equal to A divided by H. And then the degree for this case is 25 degrees Celsius, sorry, not degrees Celsius, 25 degree. And then A is what we wanted to find, delta D1x. And then divided by the hypotenuse, 850 meter. So D1x, the displacement for the x component, is 580 cos 25. (850 cos 25), the answer is 770.36 meter. And therefore, we find the component for D1y. So D1y is O. D is the opposite for this triangle. And then we have the information of H. So we use sine. So sine delta is equal to O divided by H. And then the theta for this one is 25. Opposite is what we wanted to find, D1y. And then hypotenuse is 850. So the component for the first displacement for component y, 850 sine 25. And then the answer should be 359.23 degree. And we already solved for the first one, and we have the answer for D1x and D1y. So this one will be used later. And later we are going to solve for D2. The displacement, the resultant displacement for the second triangle. Since that this is a two-dimensional problems, so that we have to divide this one into two different components, D2x and D2y. So same thing here. So this is hypotenuse, this is adjacent, and this is opposite. Therefore, in order to find the x-axis here is O. And then we have the information for H. So OH, we should use the relationship of sine. So sine delta is equal to O divided by H. So sine 21 is equal to D2x divided by the hypotenuse 560 meter. So D2x is equal to 560 meter sine 21. So the answer should be 200.67 meter. And then for this case, we use cos delta is equal to A divided by H. So cos 21 is equal to A is what we wanted to find, the vertical angle, the vertical measurement, D2y, D2y divided by H. H is 560 meter. So D2y is equal to 560 meter cos 21 degree. And then the answer should be 522.81 meter. So now we have all the answer for all the measurement for component X and component Y. Then after that, we have to find the resultant, the resultant displacement for component X. So for dx, we should add up d1x and add up d2x in order to find the resultant direction or the resultant displacement for the x component. So from the d1x is 770.36 meter and plus 200.67 meter. And then since the answer is a positive number, so we know that it's actually heading to east. And please remember that the direction north, east, west, and south. Okay, so it's a positive number to the x. So to the x is to that direction. So the answer should be a positive. After that, we are going to find a resultant displacement for the y component. So we have to add up d1y and we have to add up d2y. So the value for d1y, it should be 359.23 plus 522.81 meter. So the answer is 882.04. And since that the resultant displacement for the y component is a positive, So the y component going for positive is to that direction. So it should be heading to the north. Okay, now we break down the vector, the two-dimensional problems into x and y. Therefore, delta d is what we wanted to find. Okay, now that we have an x component, let's say the x dx, and this is dy. So in terms of vector, in order to find the resultant displacement, so you need to make this one as a triangle problem. So it's a delta d is what you wanted to find. And then the measurement for delta dx and dy is 971 and 882. So since that this is a triangle, right angle triangle, so we should solve this one by using Pythagoras theorem. So delta d is equal to delta dx, the magnitude, and plus the magnitude of delta dy. And then you can just ignore this one because the modulus is just represent the magnitude, or just represent the value for each displacement. And then this is what we wanted to find. Delta d is equal to 971.03 square plus 882.04 square, and then you square root the answer. So the answer should be 1311.83 meter. And since that this is a two-dimensional problems, and therefore we need to find what are the degree on this one. In order to find the degree, we can use another hypotenuse question, another trigonometric ratio, which is tangent, because this is a hypotenuse, adjacent, opposite. So in order to find this one, we already have the information for adjacent and opposite. Therefore, we use tangent. So tangent delta is equal to O divided by A, and tangent delta is equal to delta dy divided by delta dx, and then the value of delta dy is 882.04, and is divided by delta dy 971.03. So delta is equal to inverse of tangent 882.04 divided by 971.03, and then the answer should be 42.25. And since that this is the resultant displacement, therefore we need to state where is the direction. So we can make a conclusion that the resultant displacement is equal to 1311.83 meter, 42.25 degree, and where is the direction? North of east and of E. So this is the answer. Then we go back to the second questions. What are the skater average speed and average velocity? Okay, so when you try to find the average speed first, the average speed should be average speed. So the average speed, you need to find what are the total distance traveled. The total distance traveled is 850 meter, and then plus 560 meter stated in the questions. Okay, so the total will be 1410 meter. If you convert this one into km, it will be 1.41 km. And then after that, we have the information of the question says that the entire motion takes 4.2 minutes. So we know that the delta t is 4.2 minutes. Since that we usually find the unit of speed in terms of kmh, therefore we can convert 4.2 meter into 4.2 minute into hour. 4.2 divided by 60, so it will be 0.07 hour. And then we apply the formula. The average speed is equal to displacement divided by time. So displacement is 1.41 km and the time is 0.07 hour. So therefore the answer is 20.14 km per hour. And then we try to find the average velocity. Velocity is a vector quantity, so you need to find the displacement. The displacement is what we get right just now, this one. So we just took this value 1311.83 1311.83 meter, 42.25 north of east, 42.25. And then the time taken, same, 0.07 hour. Okay, and we apply the formula. VAV is equal to the displacement divided by the time. So the displacement, if we convert displacement into km, it should be 1.31183 km, 42.25 degree north of east, and divided by the time taken, 0.07 hour. So the answer should be 118.74 kmh, 42.25 degree heading to north of east. So that's the answer. So you can see that there's actually a difference in answer on average speed and average velocity. So that's all. Thank you.